So here we have a stoichiometry problem that involves gases. In this one, we're going to do a stoichiometry part first and then the gas law part. So it wants us to figure out the volume of the tank that we would need to hold all of the carbon dioxide produced. And so we're given the pressure that we want the carbon dioxide to be at, and as well as the temperature. So we just need to figure out how many moles of the CO2 we've got. So if we use the formula is kind of our guiding, to guide our work here. We want to know how large, so we're figuring out the volume. So volume using PV equals nRT. Volume will be N of the CO2 RT divided by the pressure. Okay. And so we know, if we just do a little check here, we know the temperature, we know R, the pressure is given to us, although it's in millimeters of mercury, so we're going to have to convert to atmospheres. So we need to figure out the moles of CO2. So we're going to do a stoichiometry problem to figure that out. And we're given, if I look at our problem, we're given the amount of the calcium carbonate to be used. So that's this part right here. And we know that there's a 1-to-1 mole ratio between the calcium carbonate and the carbon dioxide that's produced. So the stoichiometry is not that bad for us. So we go 1.25 grams of calcium carbonate. And we're going to go grams to moles for that. So grams of calcium carbonate to moles of calcium carbonate. So 1 mole, look up my periodic table and add up the formula mass for the calcium carbonate, and I get 100.0, or 100.1 for the mass there. And then, according to my equation, for every 1 mole of calcium carbonate that reacts, I'm going to produce 1 mole of CO2. So I can go ahead and calculate this for myself, and I'll end up with 0.0125 grams of the, 125 moles, gotta watch my units, right, of CO2 produced. And let's just double check our units, make sure everything cancels out. So now I can go ahead and plug that in over here into my formula. So we've got 0.0125 moles of CO2, R 0.08206 liter atmospheres over K moles. And I can see that this is going to get in the way. So let's go ahead and move the stoichiometry part out of the way here. Then we've got our temperature, which is 25 degrees Celsius. Again, we want to use Kelvin for that, so it'd be 297 degrees Kelvin, add 273 to the Celsius temperature. And we're going to divide by the pressure. Can't use millimeters of mercury, so I'm going to take my 740 millimeters of mercury, and I'm going to multiply that by the conversion to go from millimeters of mercury to atmospheres, because that's going to then cancel with the unit that we have in our universal gas constant. So I'll do the math on this. And if I did all my math correctly, I end up with 0.313, and I guess looking back at my significant figures, 3 significant figures, 313 liters would be the volume of CO2 generated by this quantity of calcium carbonate used.